right, good afternoon. I want to assume that this is an AI audience, right? Right? An AI audience. Exactly. So that what I'm going to say will not sound too off the wall, right? And it will also not sound too technically. Let me use that word. Okay, today we'll be talking about prompt engineering. Gemini and a well-designed system prompt is all you need. And when we talk about design systems, right, design systems at scale, especially when it comes to AI, we're no longer talking about traditional software systems. We're now talking about artificial intelligence systems. Now, before I go on, let me address a popular misconception, right? Because it is usually popularly said that AI is intelligent. Now, I need to say this. AI is not intelligent. AI is mimicking or simulating intelligence. So I need to say this, that AI is not intelligent. AI is mimicking intelligence. Now, you may say, what is this guy really saying, right? Why did they not call it artificial intelligence if it is not intelligent? Now, we can have that debate from now till next year. What really is intelligence? Because Elon Musk can walk into this conference and say he's the most intelligent man. But Steve Jobs can come into the same conference today and we'll start arguing who is more intelligent, right? The next thing, we have AlphaGo, we have Claude, we have Anthropic, and you give both systems a task to achieve. And you realize that one does it differently from the other. And then we begin to argue with ourselves who is more intelligent. Just about this week, we saw a new model on the leaders board come up and boast to have surpassed ChatGPT in coding experience. So the problem lies in how do we define what really is intelligence when we say artificial intelligence systems. So a little bit of background about myself. My name is Sam Ayo, and I have academic background in economics, mathematics, and statistics. I've been around playing and building AI and ML systems, from traditional systems to full inference managed systems. And I have a couple of languages in my belt, as well as some other agnostic industries I've worked in. One key play I've been doing recently is building a LangChain equivalent in Golang, right? So that people who don't use Python can also build AI solutions using Golang. So I'd like to begin by using this inspiring quote from Arthur C. Clarke that says, any sufficiently advanced technology is indistinguishable from magic. Who would have thought that some few years before now, we will be using AI as seamless as it is? I mean, I saw a post yesterday in the year 1903 when New York Times predicted that before man will be able to fly in the air, or before planes will be able to take man across the continent, to take like 1 million to 10 million years because of the way technology is going to grow. 7 days after that publication, the Wright brothers made their first flight. Right? So, advanced technology is what we get to meet or we get to experience every single day. And that's why this quote is really important for me. So, what will we be discussing today? Today, we'll be looking at what is prompting, the third-person approach to prompting, why Gemini is a real deal, and, of course, strategies to maximizing performance output. I know that in your different spheres, you'll be using AI for different tasks, right? Either as building customer service agents, building simple chatbots, or even using them as basically support systems or in productivity tools. Everything cascades down or comes down to prompting. In short, right now, okay, let me throw this out. Can everyone hear me? Let me throw this out. What is prompt engineering? Anyone? What do you think is prompt engineering? Yeah.
Can we hear me? Okay.
Yes.
Prompt engineering is all the various ways you structure your data you give AI to give you informative feedback, something like that.
Okay, anybody else wants to add to the mix? What do you think is prompt engineering? Does anyone want to add to the mix? Okay, so do you think prompt engineering is a role? I know I'm throwing a lot of stones, right? Do you think prompt engineering is a role? Do you agree? Do you think, you want to say something? Yeah? Yes, you think it's a role. Right. So, if prompt engineering is a role, do we need to take trainings for prompt engineering, or we can innovatively write prompts? Maybe I should say that again. Prompt engineering, right? We know that it's all about writing creative, clever prompts for your AI, right? So now the question is, if prompt engineering is a role, the way we take ML courses, we take computer vision courses, we take numerical data science courses, are we going to take prompt engineering courses as well? It depends. Because here's my argument, right? Anybody can open AI today, and they can write their own prompts. And prompts is English language. AI is built as a textual system. It's an AI system. It's textual. So which means that I can go there now, and I can think cleverly on how to write, how to instruct it, right? And I will instruct it to achieve what I've done. Am I a prompt engineer? Does that make me a prompt engineer? Does it mean that I can come into your company tomorrow and then I can say, I'm a prompt engineer, pay me 150K, and I'll be writing your prompts for you on a constant basis? Because there's an argument, right, on what really is a prompt engineer and what is their role in organizations. We'll look at that today. So let me quickly bounce on. Oh, why is this thing failing again? All right, so, yeah, I think it's back. So when we talk about prompting is like the bedrock of everything AI. It's like the bedrock of everything AI, right? And when we talk about prompting, we are basically saying we're talking about a process of designing and improving prompts used in a natural language system, such as LLMs. It's just a clever way of writing it. That's prompting. A clever way of writing or giving instructions to it. So when we talk about prompts, anybody can be a prompt engineer. It is not AI. It is not ML. Anybody can be a prompt engineer. And I'll tell you why anybody can be a prompt engineer. Prompting is about giving LLMs clear instruction of what to do. That is why Claude always releases Anthropic. They always release blogs of what they've done, how they did it, and then they're going to write it under there. This was experimental because there is no one size fits all to get it done. And I'll give you the basis from a technical perspective. Large language models are regressive models. Regressive models in the sense that they are basically next word completion under the hood. So which means if I tell it this today and tomorrow I tell it this, the difference between the two behavior is basically it thinking of what is the next thing to do. It's not basically saying that, oh, you wrote this thing and you wrote it from an expert level. Now, I'm not saying that there's no room for expertise. I'm not saying that if you've written prompt for so many years, you get the capability or the ability to now do it in a more efficient way when you are brought into a particular team. But I'm just saying that prompting, as it is an open role. If you have a software engineer in your team, an AI software engineer in your team, and They learn how to interact with LLMs, how to use catchphrases, and also how to use clever identity terms or idioms in the prompts. They will write better prompts than the ML engineer on the team. It's just that simple. They will write extremely good LLM prompts for the LLM. That does not take away the role of the ML or AI engineer, right? So let me carry on. What are we really talking about? We are talking about prompting being creating prompts that are clear, simple, and effective in generating the desired answer as part of the process, right? And why is this crazily important? It's super important because it covers the importance for research. It helps to test and evaluate the limitations of LLMs, and it enables all kinds of innovation. When Anthropic were releasing contextual RAG, how many of us are aware of contextual RAG? How many of us are actively building AI systems with large language models? Okay, great. And you've not heard of contextual RAG? Hi. Okay. What I planned for was actually cut short, so I think I have a lot of ample time to spare. So let me use this now to unpack this. Let's do freebies on the show. So when we talk about contextual RAG, RAG is broken down into two parts. We have naive RAG, which is standard RAG, and then we have advanced RAG, right? Naive RAG or standard RAG is, I'm brought into your team as your AI engineer. You give me your data set. Your data set could be structured or unstructured. When I say structured, it could be Excel spreadsheets, you know the like CSVs, right? Or if I say unstructured, then you're giving me PDFs, you're giving me videos, you're giving me images to work with. I have that. You give me that. First thing I do, I observe the document, I look at where it's being saved, I look at the task, I take that, and then I bring in a splitting strategy, right? My splitting strategy could either be recursive, it could either be markdown, it could either be character splitting, depending on what I want to do. So I bring that in, and then I split it, right? Chunking. I chunk it, then the next thing I do after chunking it is to do what? What do you do next? Somebody like this. Hey, ML engineers, don't fall my hand. What do you do next after that? No, you should not say, it's not allowed. What do you do next after that? I want to know for my hand. They record those. Okay, so after that, you index it, right? You vectorize it. So there you bring in your embedding model to vectorize that chunked data, convert it into embeddings. And you know what embeddings actually are, right? Embeddings are vectors that you can put in a vector DB based on computed distance and based on an algorithm to understand the similarity difference, either dot product or cosine similarity. Okay, so you take your document, your chunked document, and then the next thing you do, of course, you vectorize it. Now, after vectorizing that, you take that vectorized data, you index it or you obsert it to a vector DB. Vector DB could either be Pinecone, could either be Face, could either be Chroma, could either be Weaviate, could either be Milvus, right? Depending on whatever DB you decide to use. Now you've put that there. Next up, you query it down, right? So you have your embedding model coming again. You have a query from the user. The query is converted into an embedding. That embedding is then, sent to the database. Database do the cosine similarity by understanding either you choose a dot product or cosine. And then after doing that, it pulls down the result for you. And then you extract the text. Standard RAG. Now, for advanced RAG, that's where you now have different techniques. For advanced RAG, you don't do that. The problem with that is that the document that comes back are actually computed on similarity basis, which means you will have some chunks that are not related to the question, but because they share some level of similarity, they'll be pulled together to your large language model. What that brings up is your LLM becomes confused because it has a lot of information that makes sense, does not make sense, and it needs to decide. So you find high inconsistency across board. Your CEO is saying, what is this? What's this guy doing? Does he know what he's doing? Why are we not getting it? And then you are wondering that, what's going on? Now, we move to advanced RAG. In advanced RAG, we break the system into 3 places further: indexing, chunking, generation. Now, for your chunking, you're not using recursive character splitting, right? What you're now using, recursive character splitting is like the baseline. What you're now using is, you're now introducing document understanding to look at what really is required of me from this document. The document might be a PDF document, and in between there are tables, there are images, right? And then you need to look for a way to extract the image, extract the text, bring them together, and let the LLM see that this is coming together as one, right? So your chunking strategy, you can now introduce some things like LLM-assisted chunking strategy, right, where you have an LLM first look at the data, and that's where Gemini comes in. With a massive context window, you can chook the document in and just ask it one question. Look to this document, chunk it based on relatability of each section to each section, and let me know how the chunking will be in a properly semantically related manner. And then it brings back to you chunks. That's LLM assisted. Now, if you're not doing LLM assisted, you could do semantic relationship using algorithms like Spacey. Now, that's on the chunking part. Now, let's come to the indexing part. Now, for the indexing part, you're going to introduce 2 things. Let's talk about contextual RAG from Anthropic, because that's what brought us to the discussion here, right? For contextual RAG, Anthropic did a research. They realized that, okay, before I even say this, TF-IDF, what does it mean? Today can't be like quiz, Abby. TF-IDF, what does it mean? TF-IDF. I'm sure we have all the people that waved there and said they are ML and AI engineers. You must have done TF-IDF when we were building chatbots, then with Spacey and NLTK now. Remember NLTK toolkit? TF-IDF. Term frequency, inverse document frequency. Okay, so TF-IDF is actually a technique that is also used under the hood by Elasticsearch. So Elasticsearch works like this. It uses exact match. You know vector DBs use similarity algorithms, right? And then they look for semantic relationship between vector spaces in terms of how closely they are. Now, for Elasticsearch, it does exact match, like your dictionary. Now, what Anthropic did was that at the chunking stage, as they chunked it, they saved it in Elasticsearch. And they also saved it in a vector database in the chunking stage. So when you chunk it, let's assume we are just using recursive character splitting for chunking. When we chunk it, you know when you chunk it, right, you're also going to put the source. Am I speaking too deep? Am I speaking too deep? That was why I asked, this is an AI audience. Because the things I'm going to say are going to be technical, but they are actually concepts in the foundational level. It's really important that you know them, because they are conceptual at the foundational level. You cannot actually boast of being an ML engineer if you don't understand these foundations. It's like saying I'm a computer vision engineer and you don't know how to identify bounding boxes. It's kind of crazy, right? It's super crazy. Don't be that. There is a crusade or an evangelism I'm leading on Twitter. Don't be that engineer that cannot explain the basics. No, because you are just a consumer. You're not an engineer. You are a consumer. The people who you are using the product from are the engineers. So if we want to raise engineering talents in Africa, in Nigeria, you must understand it from the concept the ground itself, not from imports from LangGraph or from LangChain import tool or from LangChain import React agent. You must understand it. That React agent you are importing from LangChain, do you know it's a paper? It's a paper. LangChain implemented that paper. So you should know that before you are importing that and using it, it's a paper because it gives you an edge. If you want to play on the international level, right, it gives you an edge. When they ask you these questions, you can say, oh, interview, I'm going to school you. I'm going to school you. And you break it down to that the city is going to be like, this guy, we can't pay him more. Do you understand what I'm trying to say? So let's start with the contextual RAG, right? Let's continue the contextual RAG. So they have the Elasticsearch, right? Elasticsearch uses exact match. Uses exact match. Now, what your LangChain recursive character splitting is actually doing is, it is splitting it by a set of delimiters. Could either be line breaks, could be periods, could be comma. It splits that. For each splitting, it attaches the page source, it attaches the document it split from, and then it also attaches the page number to it. So what Anthropic did was that they took that, as it split like that, they saved it on Elasticsearch. They also saved it in a vector database, but it has not gone there yet because it's not vectorized, right? So they saved that unvectorized version in Elasticsearch. I already explained that Elasticsearch is a database that does exact match, right? Exact like your dictionary, using term frequency, inverse document frequency. Now, after saving that, they now take that on vectorized version that is supposed to be vectorized. They take that, then they vectorize it, and then they save it in the vector DB. That's for the indexing part. Now let's move next to the generation part, right? Now for the generation part, they pull from your vector DB. When you ask a question like, who is the current chairman of ECOWAS? It pulls context similarity from your vector DB, pulls exact match from Elasticsearch. So guess what is happening? Elasticsearch will bring exact match to ECOWAS. Vector DB will bring semantically related based on vector space to ECOWAS, which means to also bring errors, right? Then they'll bring it together and then say, what exists here that also exists here? Put it aside. What exists here that does not exist here? Put it aside. What if these two exist? Then of course it is correct because it exists here and also what exists here. If they don't match, that means it's not correct. Put it away. You see that exact match? They now take that exact match, give it to a reranker. So rerankers are actually just like embedding models. The difference between rerankers and embedding model is that a reranker will take the document, the query, look for semantically related context between that query and the retrieved document from the vector DB, and then rank it on 1, 2, 3, 4, 5, depending on how much you want it to rank. And then return that to your large language model. So your large language model is now safeguarded on like 3 levels. 1, in the chunking, 2, in the indexing, 3, in the generation. So when it gives that large language model, so one more part that also happens in the index, in the chunking, is that they now introduced another model called context generation model. They did that with Haiku using prompt catching. So when just like I explained with Gemini, they take the old document, they gave it to Haiku in the case of Anthropic now, and then they pulled out the context of all the entire document, and then they appended it to each chunk. So if you pull the chunk is already explaining what the whole document is saying. So the LLM can see that and can make more better informed decision from there. So they did that, and then they saw that the score was super amazing. Normally, they had 47% success rate with naive RAG. With contextual chunk, they had 97. The success rate was so high. So I will encourage you guys to take your time and look through that blog. It's a blog on their site. Look through that blog and also go ahead to implement it. Right? If you implement it, you see it's really exciting to learn. Okay, so let me move on. So when we talk about prompting, prompts are broken down into three parts. I'm sure you've already encountered this before. It's broken into three parts. We have the system prompt, we have the chart or instruction prompt, and then we have the what? Who can guess the last one we have? The user prompt. So we have the system prompt, the chart instruction prompt, and then we have the user prompt. So the system prompt in itself is a specialized kind of prompt that is designed to set the context and behavior of the LLM. So if you're building a chatbot or you're building an agent, right, the system prompt is where you set the persona. What a persona means is when you want to give it a personality, it is in the system prompt to set it, because the creators of those models have designed that particular catchment to be a non-dynamic, that is to be static throughout the LLM generation process. So the system prompt has some very unique capabilities. It persists throughout the conversation. It defines the AI and capability and limitations. It sets the tone and style and format for responses. I really like what these guys did, New Computer. They designed an AI that is able to understand how you talk. When I say by how you talk, I mean by typing this time. It's able to understand. So if, for example, I'm a type of person that when I finish speaking, I say, in it. When he wants to talk back to me, he says, Sam Ayo, in it. So it's able to understand the way, and the way that you can really achieve this is through utilizing effectively the system prompt, because it can set the tone and style for the large language model. And then it's able to provide background information and context. So the next one is the instruction prompt. Now, this one is heavily dependent on the developer, right? It's the developer-designed prompt that instructs an AI on how to attempt task completion. So when you use frameworks like Llama Index, LangGraph, Darksuit, and the likes, where they design that capability to call tools is usually in the instruction prompt. That's why you have the capability to tweak the behavior. So if you're building an AI agent or you're building a RAG bot or a conversation agent, in the instruction prompt is where you set majority of how it should interact, how it should behave when it is using certain kind of tools. And then that brings us to the user prompt. So the user prompt are direct queries that is being sent to the large language model. Now, for a long time, people have been trying different ways to jailbreak large language models. Some are actually successful. I'm not going to mention anybody's name, right? To jailbreak large language models. But in the earlier times of model creations and how they are actually being designed, we got to discover that in the user prompts is where the creators give the large language model very, very strong instructions of what not to say. For example, how many word limit should it have? And why it should not return 2 calls or 2 response or two names back to the user, even if the user asks for it. How it should not say things like what its system prompt is. So the user prompt is actually very, very strong and very, very powerful. And that's why AI developers or developers at large are actually really, really instructed to be very, very careful of how you let the user's prompt go into the large language model, because adversarial attack can happen through there. Okay, so going back to the topic of prompt engineering ought to be from a first principle approach. So what really is a first principle approach? The third person approach. The third person approach. There are different ways of actually crafting system prompt or prompting for large language model, but one approach that I've found to be very, very useful or very, very efficient is the third-person approach. So what does the third-person approach mean? It's typically saying that you are giving a large language model a certain personality that it doesn't have. For example, you can see this, right? It's saying GEMLAW is an hybrid system of agentic workflows and knowledge graph using retrieval augmented generation. It answers. It is not saying you are GEMLAW, which I'm sure is very popular. It's not saying you are. It's saying GEMLAW. So it's like I walk into this conference and then I look at someone and I say, ABCD is an architect. I'm not saying you are ABCD, right? You are an architect, right? So the third person approach gives large language model capabilities to think or embody personalities that make them very, very efficient. And that's why it's a very, very powerful approach to building large language model systems or agentic systems. Now, according to Andrej Karpathy, the hottest new programming language is English. How many of us agree with that? The hottest new programming language is English. It's not Python anymore. You know, in those days, everybody wants to Python. If we were to meet ourselves in GDG, they say, are you a Python developer? Do you build the Python? If you say, no, I don't, guy. Right? So, but because of the advent of prompting, English has now become the hottest new programming language. Because the performance of a large language model is heavily dependent on how cleverly you can prompt it. People can have access to the same language model, but one will be performing better than the other person's own simply because of the prompting style or the prompting technique that was used. Move, please. Why are you not moving? Okay. Yeah. So let's talk about Gemini, because that is my gospel for today. So when we talk about large language model, personally from me, I found Gemini super useful. Your choice of large language model, of course, is heavily dependent on you as a developer. But why is Gemini super useful? Right? Why is Gemini so exciting across every other large language model from what they claim or from what they build? Gemini in itself was actually shipped out sequentially, right, under the hood and then finally being brought out. And one major killer for Gemini as a large language model is the multimodality and the large context window. You don't know what large context window can do for you as an AI engineer or ML engineer, right? Because you want to put all the conversation memory. You want the LLM to remember long conversations, because the reason why me and you can look at ourselves and say we are intelligent is because even after this meeting, if he was to tell me his name, if we meet here in 5 GDGs after, I will remember his name. When we meet, I say, bro, you are this. Right? But large language models can't do that because context window is a problem. And that's where Gemini kicks the ball into the goalpost. Because with large context window, there is basically very few limitations that you have. You can stuff RAG if you're building naive RAG systems. You can maximize large conversation recall. You can even get to use large system prompts and even large user prompts. Now, but I should say this. It is not a basis for you to use large system prompts. Large system prompts become a problem generally for large language models ongoing. Because look at this scenario. I'm chatting with a large language model today, tomorrow, next tomorrow, right? It needs to remember, let's say it needs to remember just today's conversation. It is also using tools. So which means it needs to also know the tool names, the tool descriptions. It also needs to remember our conversation. it needs to also put context to what we are discussing, right? So these 4 things are going into the memory at the same time. And then I now give it a long system prompt. Maybe I want it to be the best the best AI healthcare agent in Nigeria. I gather all the synopsis from major AI systems in the world. I put it in my system prompt. I gather major clever written words and English language. I load it there. Eventually, it will become too sloppy for the large language model. So it's always great, right, that you don't have large system prompts. And this is seriously important. Minimize your system prompts. Let the prompting be clear, be astute, but at the same time, let it deliver what it's meant to deliver. So, Gemini, right, is really super exciting and useful when you're building contextual stuffing for RAG. Contextual stuffing, in this case, as I explained earlier, is where you have the entire document and you're just stuffing it in. Because, of course, Gemini models, right, variants of the models are multimodal. So which means that you are saved from that problem of how am I going to handle images? How am I going to handle images in my PDF file? So let me just also put this out there. Majority of the time when people build RAG systems, they build RAG systems that can do text, they can understand text and whatnot, and everybody's like, yeah, I just built a RAG bot, and I push the RAG bot I wrote a Medium article, I put it on GitHub. And then they are brought into a company. The company say, we want to build RAG. You then say, yes, I've done this like 5 million times. I've gone and checked my GitHub. I say, okay, this is our data set. And then they bring the PDF files. Let me use PDF now, for example. And then all through the PDF file, you are seeing tables, images. You chunk it. Of course, your chunky cannot see images. It skips the images. You chunk the table, you cannot see the table, it keeps the table. And then they now start asking questions that relate with the word and the table, and the LLM cannot respond. Right? So this is one place that Gemini plays a big game, because it allows you to perform contextual stuffing, and you can get fabulous results from that. Okay, so it's also great for document chunking. Like this is a prompt I wrote while I was designing my slide for contextual chunking, right? So it allows you to put in the document there, and it's going to generate contextual chunk for that document. And then you can use it for contextual retrieval exercises and the likes. Yeah, so it's, I think this is a follow-up. Yep. Okay. Yeah, it's the same thing. Let me move on so that I can keep to the time. All right. So let me say this before I say this. Do not chunk structured data. Do not chunk structured data. And let me tell you why you should not chunk structured data. Structured data, CSV file, Excel file, TSV file, are designed to be rows and tables, right? I mean, from our data science years now, rows and tables, of course, right? Rows and tables. And then these rows and tables, you have like a single record here, another record here, that is per row now, another record here. Now, if you remember linear regression, right? In a linear regression equation, each of those data points there, right, they contribute to how you can understand the coefficient of fit, right? That is to look at how all the data points from each of those tables there, how you can make predictions. If you chunk that, if you have like 500 rows and you chunk it, how do you think the LM is going to answer questions based on that data? Because for it to understand that data, it is supposed to be able to see the entire table and then answer questions from it. So you don't chunk structured data. Instead, you do what LLM big boys do, right? When I say big boys, I'm not talking about human beings, I'm talking about creators. So don't think there's one big boy. I'm talking about model creators, people that create LLMs, right? OpenAI, Anthropic, the Gemini, and the likes. So you create an analytics tool. You pass your CF to the analytics tool, and then when a question is asked, you let the LLM know it has an analytics tool that it can generate pandas query for, and then it can use it to answer that. I know it's a lot, right? So I literally don't even have the time to deconstruct that. But maybe in the future, I'll get the time to do that. So you don't need verbose prompts to actually use Gemini. Gemini is trained to follow tasks, instructions very, very closely. Yep, so I think I spoke about this. So let me, So while I'm closing up, XML tags. I'm sure you may or may not have come across this, but XML tags are like basically superheroes. What they're actually about is creating markdowns as instruction templates for your chat instruction format. For example, when you're passing memory, you're passing external data and whatnot. All right, so I will stop here and then I will take your questions. All right. Please, the mic, please.
Thank you, Mr. Kehinde. You actually did justice to the topic.
Thank you.
You know, most of the terms you are using, some or few of us are actually new to them. So my question is basically, I would like you to give us a proper understanding of what it means to feed an AI or what it means to educate. Like, you've been using the term several times. What does it actually mean to feed your AI or your machine? I don't know if you understood my question.
To feed it, right?
Yes.
In terms of
training, AI training, exactly.
AI training?
Yes, to train your AI. What does it mean? Like, sorry, before you continue, is it the same thing like prompting the AI to give you information back, or is there any other explanation related to that?
Okay.
Yeah, thank you.
All right, so to answer that your question, I'll break it into two parts. When we say we are training the AI, you can be training the AI foundationally, or you can be training the AI using external means. So when I say foundational, I don't mean you are building your own AI. You don't have the resources. In LinkedIn, they will say you are GPU poor. You don't have the resources. So what that means is that you are fine-tuning the large language model, right? So let's say you want to build an healthcare chatbot or an healthcare AI. So what you're doing there is that you have data of the healthcare system you are targeting. So for illustration purpose, if you are targeting pediatrics, you collected data on how doctors attend to children, the medicine they give them for different symptoms. You now take that and then you take an open source language model, maybe Mistral on the likes, and then you train it on that data. What you have done is you have shifted the large language model from a general purpose to a domain purpose. It will answer better, it will answer smarter, right? That's one part. The other part now is external source. That's less resource intensive. You can create RAG systems. RAG systems is that your data is somewhere in a database. When they ask your AI question about children's health and symptoms, it will first check there, bring that information, and then give it to the user. Did I answer your question? All right, good. Any other question? Okay.
Yeah, thank you for the session, sir.
Thank you.
Please, I would like to ask a question around how to generate a better
Can you
prompt.
please be...
Like, I would like to ask a question around how to generate a better prompt in getting like desired results using AI.
Okay, generating a better prompt. Number one, third-person approach. So let's say I'm designing the system prompt. I'm not going to say my style. I'm not going to say you are the chatbot for GDG Dev First. I'm not going to say that. I'm going to start with something like this. The assistant is GDG Dev First chatbot. So that the LLM will embody the personality that, oh, I'm GDG chatbot. You are not telling me that I am. I know that I am. They are two separate things in terms of tasks, right? So I will start by saying the conversational assistant is, or I will start by saying GDG Dev chatbot is a multimodal, super intelligent assistant for GDG 2024. So starting off by then you now move on and then use it. So instead of me to say, you are GDG Dev first chatbot, you know how to do this, you know how to, I would say, the conversational assistant GDG chatbot, it can. So when you do that, it now embodies those capabilities as its own. When the user is chatting with it, you need to tell the user that, oh, well, I can. It will boldly say, I can do all this kind of stuff. Did that answer your question? Okay, any other question? Okay.
Thank you, sir. You spoke about the RAG,
Yes.
right? So you talked about that it's putting some, let's say, some responses in a database, right? And the AI goes there to pick. So doing that, do you give the AI a prompt to check the database first, or there's a way the integration has to happen for the AI to utilize the prompt, the RAG system first? And is there a way to configure your AI, all right, to maintain its response within a local database?
Okay, great. So two ways you can solve that problem is you can use a framework. If you're using LangChain or Llama Index, LangChain allows you to do knowledge retrieval using their knowledge retrieval class. If you're using Llama Index also gives you that. But if you're building natively through their API, you need to cleverly design your own prompts. So that's where XML tags comes in. The XML tags are a very excellent way for large language model to understand things because that is what is used in their training data. So if you give them things like JSON, initially they were struggling seriously with JSON until we had the big blow with JSON output now being an integral capability. But going back to the basics, first principles is XML tags under the hood, right? So you can use XML tags to write the prompt, and then you can start off by saying, right, the assistant is there. Whenever the user is asking you a question, first check that you pass the data for the database. First check here. If you don't have that response there, tell the user, I don't know. That way you have caused hallucination. Because if you don't do that, it's going to say, okay, I did find information, let me tell you what I know. And what it always knows is outdated. Did I answer your question? All right. Any other question? Okay, if there are no other questions, thank you so much, guys. It's an honor.